Okay, guys, I'm sorry that I couldn't be here to help you review for your quiz today. You all know why I couldn't be there. But in order to help you prepare for your quiz, I am going to make a short video and go through as many of these as possible. I want to keep this video as short as possible, so I'm thinking I'll probably go through the odds and not the evens. However, I will post a complete answer key with the evens. It's just that you won't have an explanation for the evens. So hopefully you'll be able to figure it out just from the answer key that I will scan in. And you can use this time to study and get ready for your quiz, which the sub will be administering for you. So let's jump right into this. Simplify each expression. We are looking at rational expressions. Remember, a rational expression is just a fraction. So all we need to do is factor and cancel out like factors, not like terms. Remember the difference. So here, let's see, in my numerator, we have 16m cubed. I like to break my numbers down all the way into prime factors. So let's see, 16, 2 times 2 times 2 times 2. We could double check that. 4, 8, 16. Perfect. Times 3m's. I'm going to run out of space. Okay, in my denominator, I just have 10, so that's going to be 5 times 2 and 2m's. M squared is m times m. Okay, all factored out, prime factors, and we're going to cancel out factors that are identical. So here's an m, here's an m, and a 2. Okay, so whatever's left, you're going to multiply together, and that is our final answer. So in the top, 2 times 2 times 2 is 8, and the variable that's left over is m. Divided by, the only thing left in the denominator is 5. Done. Number 3. Again, we have a monomial, so we're going to break this down into prime factors. 12 is going to be, let's see, 2 and 6. 6 would be 2 and 3. So 2 times 2 times 3. And then 3 n's, 1, 2, and 3. All right, 24. Let's see, 2 and 12. And then we can just do the same numbers we did for the 12 on top. 2 and 6, 2 and 3. So 2 times 2 times 2 times 3. Just basically one extra 2. And then a single n in that denominator. So we will cancel 2's, 2's, 3's, and one pair of n's. Final answer, what's left? We have n squared at the top. In the denominator, looks like just a 2. N squared over 2. All right, number 5, we have quadratics, so we're going to need to factor. You can use a diamond if you want, but like I've told you guys a million times, it's not completely necessary. All right, so in the numerator, we have a 72 and negative 17. So I need multiples of 72 that add up to 17. Interesting. 8 and 9. Both negative. So we're going to have an r minus 8 and an r minus 9. Okay? All right. In the denominator, we have 1 times 6, so negative 63, negative 2. So multiples of 63, that get me to 2, 9, and 7. Negative 9 plus 7. Okay. So now we're going to look for factors that are identical, both r minus 9. Final answer, r minus 8 over r plus 7. Number 7. Again, quadratics. So you can use the diamond if you'd like. 63 and 16. Let me think. I'm thinking 9 and 7. Both positive. Okay. In the denominator, let's see, 81 18. Oh, that's going to be 9 and 9. So b plus 9, b plus 9. All right, we're going to cancel identical factors, b plus 9, top and bottom. It can only cancel with one of the b plus 9s. Okay, won't cancel out both. So we have b plus 7 over b plus 9. Okay. Number 9. All right, we have a binomial in the top and bottom here. So all we need to do is factor out a GCF. In the numerator, my numbers are 10 and 30. So the biggest number that's going to divide into those are 10. And then I have k minus 3. In the denominator, 5 and 25, my GCF is 5. And I have 5k plus 1. All right, so it doesn't look to me like any of my factors are going to cancel, but these coefficients out to the front, I can reduce those. So 10 divided by 5 is 2, and then k minus 3 still in the numerator. In my denominator, all I'd have left is that 5k plus 1. Okay, flip over. Number 11. We are multiplying. Remember what we said about multiplication. We are just going to create one fraction, because when we have two fractions that are being divided, we divide across the top and then across the bottom. So I have 1 times this quadratic. Anything times 1 is just itself. So that's all we have in the numerator. In the denominator, I have 9 times k plus 3. Those are different factors, okay? So let's factor this out. In the numerator, let's go down here with it. In the numerator, I need multiples of 12 that get me to 7, 3 and 4, both positives. So we'll have a k plus 3 times k plus, 4. And that's divided by 9 times k plus 3. Any factors that are identical will cancel out. And I am left with k plus 4 divided by 9. Okay, moving on. Again, multiplication divides straight across the top and straight across the bottom. So let's see. We're just going to put these two factors next to each other. Leave them factored out. Okay. Divided by, same thing here. We're going to leave these factored. Let's leave it alone for now. 6m plus 20. Okay, right off the bat, I see these 6m plus 20s. So I don't need, I mean, you could factor out a 2 from each one, but there's no point to doing that because they're identical already. So all we have left here, excuse me for all the coughing, is 10m over 3. Okay. Number 15. Maybe I'll get this video done in under 10 minutes. That would be a record. We have p minus 1. Well, hold on. I'm sorry. I jumped ahead of myself. We're going to multiply straight across the top, straight across the bottom, one fraction. Now we have the factors p minus 1 times that 9p squared minus 45p. Okay. And in the denominator, I've got 9p times p minus 1. All right. So it looks like everything is pretty much factored. This can't be factored. 9 could be broken up into 3 times 3. We'll see if that's useful later. P minus 1. Okay. The only thing I'm seeing here that needs to be factored more is this parentheses right here. So I'm going to just focus on that. If you want to cover up everything else for a second, you can. I'm kind of running over into 16. All right, so the only thing I can factor out of here is 9. 9 will go into 45. And they also have a p. So I'm going to take 9p out to the front. And I have p minus 5. And I did not forget about that p minus 1. It doesn't matter which order they go in, which one goes first, which one goes second. It really doesn't. In the denominator, 9p times p minus 1. Okay, so we have a couple of things here that are going to cancel. P minus 1, 9p, Final answer, only thing left is p minus 5. We're at the 10-minute mark. I'm not going to be able to do it in under 10 minutes. That's okay, though. All right, 17. Now we're getting into problems for division. So remember what we talked about with division. We're going to change to multiplication. Mult. And flip second fraction. Okay? Put a little star there so you remember. So here's how this is going to go. Your first fraction, the a minus 1, is going to stay the same. And you know what? I'm just going to go ahead and factor this while I'm at it. So in my denominator, I can take this 10 out to the front, and I have a plus 1. Okay, first one's done. It's already factored. We didn't flip it. It's ready to go. We're going to change it to multiplication, not division. And we're going to flip this one. I'm going to move this to the top, and 7's going to come to the bottom. So 7's going down here. And you know what? While I'm moving the denominator up to the numerator, I'm going to go ahead and factor it too. I can see that they both have 14. So we'll take 14 out, a plus 1. All right, when you are multiplying fractions, you just go straight across top, straight across the bottom. So right away I'm looking and I can see that these a plus 1s, they're gone. And now I have some coefficients. I've got 14, a 10, and a 7. Well, I know 14 over 7 can be reduced to 2 over 1. I guess I should put 1 down there. All right. And now that that's a 2 and this is a 10, I can even reduce these because 2 over 10 would be 1 over 5. So now this 2 is a 1 and it's over 5. So let's see, what do I have left here? In the top, a minus 1 times 1. Anything times 1 is just itself. Divided by, well, the only thing I have down here left is 5 times 1, and that's 5. So, final answer. Okay, 19. We have 15r cubed minus 27r squared over 2r. Change it to multiplication and flip. 2r over 50r cubed minus 90r squared. Oh my goodness. Okay, so when we are multiplying fractions, like I said a million times, change it to one large fraction, multiply straight across the top, straight across the bottom. Now, before I even start factoring, I can see these two r's are going to cancel each other out. That makes my life a whole lot easier. So let's see, all I have left now in the top is the 15r cubed minus 27r squared. So let's see, do I have, let's see, I know 3 can go into 27 and 15, so let's take a 3, and the largest amount of r's I can take away from both is 2, so r squared. And I have 5r minus, I'm having a brain fart, 9. Okay, now in the denominator, I have 50r cubed minus 90r squared. Well, these are both 50 and 90. They both have a 0 at the end, so I can take out a 10, definitely. So 10r, the most I can take is 2r, so r squared. 5r minus 9. Oh, looky, looky. 5r minus 9 is gone. So is r squared. And all I have left is 3 over 10. All right, so I'm going to go ahead and finish all these evens and then scan it in for you guys so that you can have something to look at and check your answers. Your quiz is not that difficult, I promise you. I'm looking over it right now. It's actually right here in front of me. And here's a little sneak peek. Nothing with a leading coefficient. Oh, wait, here, but once you factor out that 3, it'll work out beautifully, okay? So I'm looking. You will not need the diamond method for this. All right, number 8, there's a lot of factoring, but no diamond. You don't need it. Some of you use it for a leading coefficient of 1, and that's perfectly fine, the same way I did right here. These leading coefficients were 1, 1, 1, 1, but I use the diamond method because I'm seeing a lot of you do it, but you don't need to. A lot of this can be done in your head, okay? So do what you can with your quiz. I will be lenient, and again, like I said, I'm sorry I couldn't be there, and thank you guys for being so patient and understanding while I handle some personal issues, all right? So do well on your quiz, do the best you can. I will see you guys on Wednesday. Have a good night.